Section 5.4, and we're going to start this chapter by doing something called the sum and difference formulas. So we know that there are a lot of angles around the circle, not just those that we found on your unit circle. So we know that these are not the only angles around the unit circle, that there are an infinite many of them. And so now we're going to kind of branch into talking about all of those angles out there that are not on our unit circle. And we use something called the sum and difference formulas, and here they are in all their glory, and they're a little cumbersome to look at first, so I kind of want to get into the example and then I'll show you how they're used. So this first one just says, can you please find the exact value of the cosine of 75? As soon as you see that exact value, that pretty much means you can't use your calculator, because we want a fractional answer, and so we need that to come out as an exact, not an approximate, and those decimals on your calculator are approximated. So we're going to come up with actually using two angles on our circle that we already know to get to 75. So I already know the exact value of all of these around the circle. So why don't I use two of these that would get me to 75? And the two that are kind of the most obvious to use are the 45 and 30. If I add those two together, they actually make 75. And I already know the exact values of these two. So it makes it kind of easy for me to kind of convert 75 into using two angles that are actually on my circle. So I'm going to turn that 75 into cosine of 45 plus 30. And now I'm going to pick out my sum and difference formula. So what these are essentially saying is, if you're doing the sine and you need to add two angles together, here's the formula you could use. If you need to subtract two angles, we'll do one of those in a minute, here's a formula to use. If we're doing a cosine plus, which is what we're doing, this is the formula we want to use. So we're going to do cosine of each angle, no matter what these are. We're going to do cosine of each, and then we're actually going to subtract. So if you notice, you've got a plus there, but you subtract in the formula. Same with subtraction turns into addition. In sine, they're actually the same. So plus is a plus, minus is a minus, no big deal there. But in cosine, they flip, so you do need to watch that. And then it goes sine and then sine of both angles. So it's cosine, cosine, and then sine, sine. So I'm going to start off with, I'm actually going to wrap it around down here so I don't run into that one. So cosine 45, cosine 30, and then minus sine 45 and sine 30. And these are being multiplied in between each pair that we've got going on. So just watch that too, that you don't accidentally make it look like subtraction. That sometimes happens for students when our writing just gets a little quick and sloppy. So this is all multiplication. So first off, it says, what is the cosine at 45? So I'm going to go to my unit circle. I'm going to go to 45 degrees, and the cosine there is square root of 2 over 2. Times the cosine at 30. So back to my unit circle, go to 30 degrees. The cosine is square root of 3 over 2. The sine at 45 should be square root of 2 over 2. And the sine at 30 degrees should be a half. And that's pretty much the end of the pre-calculus. The rest of it is just a little bit of algebra. So when I multiply roots, they actually multiply together. And then I have square root of 2 over 4. And since they have a common denominator, we tend to put them together. And this would be my exact answer of the cosine of 75. So again, if you typed in cosine 75 on your calculator, it could totally do it. It gives you a decimal. Your calculator cannot switch that decimal since it is irrational. It cannot switch it into this exact answer with the roots. So this is just us doing the process of finding an exact value. So now let's switch over and do sine. And your notes packet should just be pi over 12. So I'm just crossing that off because I made a typo on mine. So yours should just say pi over 12, which is a little tricky. Like, I don't know where pi over 12 is. It wasn't nearly as easy as 75. I don't see a pi over 12. I don't even see over 12s on here. So what I'm going to do instead is turn this into degrees, and hopefully seeing it in degree will help me figure out where the angle is and what I can add or subtract to get there. So I'm going to multiply this by a 180 over pi. I'm going to cancel out the pi's, just grab my calculator, and then I've got 180 divided by 12. So I get 15 degrees. So that's the angle we're looking for. Now the two easiest angles to use that you could add or subtract to get to 15 would be 45 and 30 again. But you could use 60 and 45. They do it. 135 and 120. You could use any pair of these because subtracting any of them will get you to 15 degrees. So I'm actually, just for fun, going to use 330 and 315 just to show you that I can use angles anywhere. So sine of 15 degrees is going to turn into, for me, 330 minus 315. Again, doesn't matter which two angles you use, just as long as they get you to 15 degrees. So you can pick any two. For right now, our angles have tended to be in the same quadrant. That also doesn't have to be true either. So when you get to your homework, if you get an angle and you end up using, let's say like 60 and 240, so be it. They don't have to be in the same quadrant. They can be anywhere on the circle as long as they add or subtract up to the angle you are trying to find the exact value of. So I'm using sine of 330 minus 315, so I look at my sine minus formula because I'm subtracting two angles. And it goes sine of the first, cosine of the second, and then minus, and you kind of flip-flop them. So I'm going to do sine of 330, cosine of 315, and then flip-flop, so we've got cosine of 330 and sine of 315. So you get one of each angle when you're done kind of plugging everything in. Oops. And you should see no repeats at that point. Everybody should kind of appear once. So now let's go to 330 degrees. And the sine there is negative half. At 315, the cosine is square root of 2 over 2. Cosine at 330 is square root of 3 over 2. And 315 for sine is negative root 2 over 2. So now we'll just do our little bit of algebra, a little bit of simplifying. Remember, anytime you are multiplying, you multiply just straight across. So we've got a negative root 2 over 4. And then we've got a minus minus, so those will turn positive, root 6 over 4. And just putting them together, root 2 plus root 6. I should point out that the order is not important as long as they have the right sign. So if you picked out two different angles to get you to 65, your answer might have turned out like this. And we are the same answer. I have a negative root 2, yep, and I have a positive root 6, yep. So this order is not important, just as long as you have the negatives and the positives on the right root. Same here, this could have come out if you'd have picked two different angles. Maybe you ended up with square root of 6 minus square root of 2 over 4. They are the same, just as long as your negative is on the right thing, negative is on the root 2, and your 6 is positive. Since every time you do one of these, you're going to end up using the square root of 2, square root of 3s, and halves all around your circle. Those are the only values you get to play with. Your answers will always be some kind of combination of root 2 and root 6. Maybe they're both negative, maybe they're both positive, maybe one is negative and one is positive. So if you don't end up with root 2s and root 6s, you can kind of back up and go, all right, there's a mistake somewhere because that's what I should end up with. So when we're pulling values right off our unit circle, we're using the same ones every time. We should be getting the same type of answers every time. So now, of course, let's do one that's not on the unit circle. This one doesn't even tell me what the angles are. It just tells me that there are two different ones. One of them is U and one of them is V. And they tell me where they are. 0 to pi over 2 is in quadrant 1, and pi over 2 to pi is in quadrant 2. So just like last chapter, we're going to draw ourselves some triangles sitting in those quadrants, and then we'll be able to use our formula. So first off, I've got my U triangle sitting in the first quadrant. So I'm going to put a U in there. The sign is 4/5, so 4 over 5, and then that will be a 3. That's a Pythagorean triple. Excuse me. Next up, we've got our V triangle, which actually happens in quadrant 2. I'll draw that one, put a V. It told me the cosine was adjacent over hypotenuse. Doing Pythags, I would get a 5. So here we are sitting with our two beautiful triangles, and now we just need to use our formula. So it says do a sine U plus V. So we're doing a sine plus formula. So I do sine cosine, and then I flip-flop them, cosine sine. So U comes first, I gotta do U first. And then plus, and then flip-flop them. So now I go to U, and I give the sine value, 4/5. I go to V, and I do the cosine value, negative 12/13. I go to U, and I do the cosine value, 3/5. I go to V, and I do the sine value, 5/13. So that was the pre-calculus, and now we've got just their algebra. So 4 times negative 12 ends up being negative 48 over 65. And then we've got 3 times 5 gives you 15. And adding these two together, you get negative 33 over 65. So So that was just an example of where you might have to draw your own triangles in order to figure out what your values are for your two angles. Again, I don't care what these angles are. I don't care what their measure is. I just needed to know some information about them. So using the formula doesn't mean you have to know what the amount is. You just need to know the values at those angles so you can keep going. Last one says, can you just simplify? So again, try to see this as just two angles being added together. And so we are going to use our addition formula under sine. So sine's formula up at the top of your page says sine of x cosine of 3 pi plus cosine of x sine of 3 pi. So you need to get in a place where you kind of see that addition and you see it as two different angles, that we are going to be adding together, and then we'll use our formula. So our two angles happen to be an x and a 3 pi, and we just fill in the formula and let it all fall where it falls. So sine of x, I can't do anything with that. I don't know what it is. Don't care. Cosine at 3 pi, though. So I go to my circle and I go, okay, where's 3 pi? Well, I know there's 1 pi right here. There is 2 pi right here. So it kind of stands to reason that this would be 3 pi. And I'm supposed to give the cosine there. So that's -1. And then I've got cosine of x again. I don't know what this angle is, so I can't do anything about it. And then it says sine at 3 pi, so going back to that, I would have 0. And 0 times anything is 0, so I don't even care about that. And then -1 times sine would just be negative sine x. And that's what they're calling by simplifying. It's just kind of using the formulas to break it apart and see where you land. So your sum and difference formulas today are all about you breaking an angle apart, like 75, breaking it into two things you know, and then using the sum and difference formulas the way they're set up to find the exact value.